Mango Math presents Taxicab Treasure, a pre-algebra game. Taxicab Treasure is a pre-algebra game which has students understanding numbers in ordered pairs as indicating location in a quadrant of a coordinate plane. They'll also learn a little bit about Euclidean distance. Taxicab Treasure Hunt has some math terms to help increase understanding. Euclidean distance is the shortest distance between 2 points being a straight line. It is solved by using Pythagorean theorem. And Pythagorean theorem is the area of the square built upon the hypotenuse of a right angle is equal to the sum of the areas of the squares upon the remaining sides, which is the same as x squared plus b squared equals c squared. And if you want reference on how to solve for Pythagorean theorem, please look at Pythagorean baseball. The supplies that are provided in the pouch along with your information sheet and directions will be 2 laminated Taxicab Treasure maps, a dry erase marker, and an eraser. To start this activity, one student, without the others seeing, will be the person who hides the treasure. They can put the treasure anywhere on the board that they would like to place it. And so let's say I put my treasure right there. I'm going to mark it with a star so you can see it better. And I am going to then figure out, and I'm going to remember that spot. And I'm just going to keep my board hidden from the other players. So the other players will have the board and they can take turns guessing where the treasure is based upon clues that they're going to get. And the clues will be how many blocks away they are from the treasure. So the first person that goes can pick where they want the cab to be anywhere on the board. They can put their taxi cab anywhere. I'm going to be easy on this one and say I'm just going to start on 0, 0. So my first coordinate that I'm going to write down is 0, 0. Then the player who hid the treasure is going to tell me how many blocks away I am from the treasure. So if you look at the person who hid the treasure's board, you can see over 2, over -2, and up 4 is going to give me being 6 blocks away. So I'm over 2 and up 4, so I'm a total of 6 blocks away. So I'm going to write that down on the game board. I'm 6 blocks away. So now they have that clue. So now the person who put the other person, if there's 2 people playing, trying to find the treasure, he can place an X anywhere on the board that's going to be our next location. And let's say he chooses a total of 6 blocks away. I went over 3 and up 3, so that's 6 blocks away, and I'm now at the coordinate 3, 3. So now the person who hid the treasure is going to tell me how many blocks away I am this time from the treasure, and once again, I'm 6 blocks away. So I'm 5 blocks plus 1 block up is 6 blocks away, but the people that have the hidden treasure don't know where I am, so they're going to keep guessing. So the next logical guess that they're going to use some logic is that I'm still 6 blocks away. So it's not likely it's going to be in this quadrant that I'm in. So I'm going to just guess maybe south of here, and I'm going to go down just a straight down 6 blocks. So that gets me at the coordinate that's still 6 blocks away from that original 0, 0 place. And I'm going to write down where that place is, and it's a 3, -3. So now I have that coordinate. The player is going to say where I'm at, and they're going to say I am now over 3, 4, 5, over 5, and up 7. So I'm actually now 12 blocks away. So I've gotten farther away. So now the next person's turn, and they get to guess where I'm going, the treasure is located, and they're off the information given. I am now 12 blocks away, so I'm too far away to be anywhere in this coordinate, probably too far away to be anything in the other coordinate, the -, coordinate. So now I've got to kind of decide I must be in the -x positive y coordinate. So I'm now going to figure out where my next spot's going to be. I'm going to move 12 spaces from where I was because I'm 12 away. And I now have that new spot, which is, if you look at the treasure map that has a star on it, I'm right there, and I am actually 2 blocks away. So now they would write the new coordinate down, -3, +3, and say 2 blocks away. And now the person has to guess where I am with relationship to that one. So it's a lot of logic being used, but they're also going to learn coordinate points, where they go within the grid to find their location. If this board seems a little too busy for them with the little houses on it, just print out a regular coordinate paper and have them work on that. So some guided thinking to promote some guided questions to promote critical thinking. Is there more than one way to reach the treasure location? There actually should be lots of different ways that they can get there because they have the whole coordinate grid to work with. And if the coordinate points are 2, 3, and 5, 8, what is the Euclidean distance? So once again, Euclidean distance is the shortest distance from point A to point B, which is normally a diagonal line. And so if you figure out the diagonal, that distance, you use Pythagorean theorem to do it. And if you need help on Pythagorean theorem, look at Pythagorean baseball to help you. But it's a squared plus b squared equals c squared. So enjoy the activity. Kids love this one. It's a lot of fun to do.